Hey everyone, welcome you all to the first episode of Coffee with Cosmos DB series. This is an initiative to spread the knowledge on Cosmos DB. So whether you are a Cosmos DB enthusiast who is looking to learn or a beginner, this channel has something for you. This channel is completely driven by the community for the community. Also, just to talk about the series, this is going to be a bit different. We are planning to host experts and community members in this channel to share their learnings on Cosmos DB with some interesting demos. We will keep it short for 10 to 15 minutes so that you can learn something new in short time. Subscribe now and join us this exciting journey into the world of Azure Cosmos DB. If you are interested to present or if you have feedback, please use the chat or reach out to me using the Twitter handle. All right, today we have our first episode uh, with special guest from the Cosmos DB team, Sandeep Nair. Without a further ado, let's jump into the discussion. Before that, Sandeep, would you like to introduce yourself?
Hi, Saji. Hi, everyone. I'm Sandeep. I am a program manager in the Cosmos DB team, and I'm based out of India.
Cool. So today we are going to cover why Cosmos DB for relational developers, right? This is a common question that comes across all the developers' mind. So we will drive this conversation as a um, demo-based plus you have some slides as well so that you can present and explain those concepts. So I'm going to put you on the spot and ask some of the common questions that we get as a developer. So first question, right? Cosmos DB fully being a managed NoSQL and a relational database for modern development scenarios, and it's the only NoSQL offering in Microsoft. So what are the design differences to keep in mind when building application dealing with NoSQL databases? Basically, difference from SQL, mindset.
Sure. So if you are a relational developer and you have been working with relational databases, working with NoSQL databases is going to be a little different. The thought process itself is a little different. So first thing that we need to understand is what is NoSQL. When we say NoSQL, we are talking about a non-relational database, which basically means the concept of primary keys, foreign keys are not there. There are no tables which are connected to each other. So those relational concepts are not there. So you don't, and then since there are no foreign key, primary key relationships, there are no joins. So basically your data is not inside multiple tables. You may have everything in single table. Second thing is there is no schema. So when we say schema in a typical database, we talk about, okay, my table has got 5 columns. And if I have to make any changes to those columns, then that's a big problem because then everything underlying also needs to be adjusted. So you have to have your schema identified upright. You have any change in schema is considered not to be done. Often it's expensive to make schema changes, etc. But in NoSQL, there is no schema. There's basically you just need to mention that every document or every record just has got an ID. Rest of it is flexible. You can use whatever schema you want to use. And later, I will just show you an example of that also. And the last but most important difference is when you define your NoSQL database, you are having a query first approach. Basically, which means that you are creating your database in such a way that your queries execute the fastest. You don't need to be normalized, which basically means you can duplicate data. Doesn't have to be uh, you know, no normalization doesn't have to be done. And last is that sometimes you have to use materialized views to take care of your requirements. So these three things have to be kept in mind, and these are very different from how you would design normal RDBMS. So yeah, keep this thing in mind, and you will it will be easy. So to explain difference, why would somebody use the NoSQL? That's the next thing that comes up, because why are we doing all this? What is the difference? So when we use NoSQL database, we are able to handle huge data needs because the database is designed to handle that kind of high throughput. Similarly, low latency, because again, data is available readily. It is served by the database faster. You can have low latency requirements. Uh, NoSQL would be a good fit only if the relationships are not the most important thing. So if you are building, if you have a software where the relationships between the table, and you have got many entities, and those relationships have to be enforced, referential integrity is important, then NoSQL is not the right place. You may still want to use RDBMS. And one more third place where NoSQL can be of great use is where either the schema is inconsistent or the schema keeps changing with time. You have to have a flexible schema, because when with an RDBMS, like I said earlier, schema change are expensive and difficult to handle.
All right, Sandeep, I think one of the important characteristics of Cosmos DB is, since it's globally distributed, and one of the main characters is the scalability, right? Can you explain more about horizontal scaling? And basically, what do you mean by horizontal scaling on Cosmos DB?
Sure. So as you see on the slide, Cosmos DB basically is built using multiple nodes. So Cosmos DB is a horizontally scaling database. What I mean by that is that by default, let's assume that when you provision a Cosmos DB database, you get one node and or one partition here which has got all the data. Now let's assume that your data grows and it becomes bigger, or you have to add a new geography. How does this partition scale so that it's available in another region, or you are able to store more data, right? The simple, we do not have different sized partition. All the partitions in Cosmos DB are same size, so you cannot grow it. What you could do is, when the size grows, you create another partition. So basically, horizontal scaling basically means add more objects so that you can spread the load, right? So Cosmos DB uses horizontal scaling as the construct for scaling out. And here, when we talk about one partition, we are actually talking about 4 replicas in the backend, 1 leader and 3 followers. So this is to make sure that even if one replica failed, you do not have downtime. System is fault tolerance, and to handle that. So basically, when we talk about the smallest unit that you would be able to deploy is a partition, and one partition would have 4 replicas. So now, depending on the size of your database, depending on how much throughput you want, depending on how many regions you want, you may have n number of partitions, right? So you can see that here, if suppose there are data about London, New York, Paris, and Rome. London may have more data, so it is stored in one partition. New York City and Paris, because they have got not so much data, they are sharing a partition, whereas Rome is again having an independent partition. So as more cities come in, or as data grows, they will be accommodated in one of the partitions. Yeah, one thing to note here is that this distribution is done based on the partition key, and one partition key will always be restricted to a single partition. So you will not have one partition key spanning to multiple partitions.
All right. I know the fundamental concept in Cosmos DB is choosing the right partition key, right? So why partition key is important, and can you explain more about the concept of partitions in Cosmos DB?
Yeah, so very good question here. So as you see again in this picture, we talked about partitions being there and more partitions getting created depending on throughput requirement, space requirement, or region requirement, right? So now question is, okay, if I have got data, where is my data stored? How does Cosmos DB go and fetch that data in a very fast manner so that it can be served to the customer? That's done using the partition key. The partition key basically tells you which partition to go to and get the data. So data, when stored in Cosmos DB, is stored in logical partitions, and a logical partition is identified by a partition key. Like I said, a logical partition cannot span more than one physical partition, so it is always inside a physical partition. And Cosmos DB maintains a map to figure out which partition this data is. So when you write a query and say, okay, select star from, let's say, some table where partition key is equal to city, it internally is or city, whereas in this case it will be London. Let's say a city is equal to London. It automatically knows that London partition is on this partition. The query comes here, it gets executed here, and the results are shown back. So identifying the right partition is important. Now, the important part about partition key is, because that is the mechanism of sharding the data or distributing the data. If you select a wrong partition key, you may have a query where the data is available not in, you're not able to identify the partition very clearly, right? Assume that you have partition by city, and now you want to, let's say, search by population, right? Now, population, the system doesn't know where to look for, so it will go and send the query to each of these partitions. So it will work, but it is going to be more expensive, and also it will take some more time for the query to execute. So partition key helps you to reduce cost, and it also allows you the system to function in the most fast manner.
Got it. Let's check if there are any questions on the chat. I don't see any questions.
Yeah, so while we are waiting, I just wanted to also show you a small concept of the schema thing where I wanted to highlight. So in a RDBMS, typically, if suppose you're creating an online store, you would do something like this, where you would create a products table, and then you would create 3 tables, one for shoes, one for books, and one for computers, purely because the fields or the columns are different here. So if you want to get the shoe details, you would join the products with shoes. If you want to do the book details, you will do the join of the product and books. So you would have to join all these tables to get data. Now, if you want to find data which is, let's say, based on color, just say I want to look for everything which is black in color, it would have been difficult because I don't have, let's say, I don't have a color black here. So let's see. So yeah, so if I were to search for something based on a single property here, it would have been difficult because I would have to join between 3 tables. So, but when it comes to NoSQL database, and specifically Cosmos DB here, I'll just show you an example of how easy it is to do. So here in Cosmos DB, I have stored the same 3 documents as 3 JSON objects. So in NoSQL Cosmos DB, we store everything as JSON here. So we have the shoe record, we have the book record, and we have the computer record. All 3 have got different schemas, but if you see, all of them are stored inside the products container, which is equivalent to the table in an RDBMS. Now, I don't need to really do any joins. Everything is stored independently. So when somebody asks me to give me a data, I can give this data as it is. So that's why the system is very fast. And let's say if somebody is interested in knowing, okay, give me all items which are black in color. I don't know whether they are shoes, books, or toys. If I execute this, the system will go and get me all objects which are black in color. Right? So you can see that the 2 objects were returned. The first one is a shoe, which is black in color, and the second one, sorry, just a second. The first one is a shoe, and the second one is a computer, which is black in color. So, and now if I have to go to I want to create a new item, and I say I want to create an item, let's say its ID is ABCD, and let's say its type is, let's say this is a car. I'm going to keep it short. And again, this has got a color which is black. Then let's see what happens. Let me just make sure that the spelling is case sensitive. Yeah, so I just want to make sure. Yeah. yeah, that's a document. I'm just saving a document which has got just 3 attributes. I'll click on save, and this the third document has been saved. And now if I execute the same query, you will see 3 records coming out, which is one is the shoe, the second was the computer, and the third was the car. So it's very easy for you to develop your applications using NoSQL. You can keep adding more objects, don't have to worry about schema. You worry about what data you want to query about and create your documents accordingly.
All right. Thanks for sharing the demo. I think so. How do you interact with Cosmos DB NoSQL API? Do you recommend any SDKs?
Yeah. So when you talk about interacting with Cosmos DB, Cosmos DB comes in multiple flavors. Let's talk about the NoSQL API first. When we talk interact with NoSQL APIs, we have got SDKs available. We have got SDKs available in all popular languages. We have it in .NET, Java, C Sharp, uh, uh, Go, Python, JS, etc. So you could use the SDK which is most appropriate for you. We have connectors for Spark and many other Azure-based services also. So you could use Cosmos DB in those services also. But when it comes to the other APIs, which is like Mongo, Cassandra, Gremlin, etc., we don't have any SDKs of our own. You can use the open source SDK because we have a you know uh, no, our APIs are compatible with the open source APIs. So you could use any of the open source libraries that are available.
Yeah, thanks for sharing all these insights. I think we are almost on time. Let me see if there are any questions. There is a new question coming up from one of the user. So he says that my product needs simultaneous writes in several geographics. Does Cosmos DB take care of it automatically, or do we need to change our application logic to make sure all users see the same data?
No, actually, this is a very nice question. So one of the powers of Cosmos DB is called multi-master, which basically means that you could deploy Cosmos DB in multiple regions, and all regions are write regions. So it's like an active implementation. And when you configure your SDK to write into Cosmos DB, you provide a list of preferred regions. So let's say you have one client sitting in the Americas and writing to the American Cosmos DB, and then you have another client sitting in India and writing to the Indian Cosmos DB. As far as you as a customer is concerned, you really don't need to worry about how does this data get synced, how do you make sure that all data is consistent. You can just write into your the region that you are in, and Cosmos DB behind the scenes will make sure that all data is synced and available. Now, when I talk about that, there are 5 consistency models also available. So by the default consistency session, so you could also ensure, for example, you could go to the strong consistency and make, in that case, what would happen is that when a write happens to one region, it will wait for that replication to happen to all other regions and then only commit that write. Otherwise, it will not commit it. So in that case, as soon as your one write is complete, it's replicated to all the regions and it's available in all regions. And then you also have the eventual consistency, in which case you can write and forget, and eventually it will get synced up. It may take some time. So depending on your use case, you may use the consistency model which is most appropriate for you. But again,
I
no
hope
code,
that
it's all managed by the platform.
got it. Okay, I hope that answered the question. Yeah, I guess that's all we had on the question side, and that's all for the session today. Probably, yeah. Since this is the first session that we are having as part of the series, I know that many of you were not able to participate, but we would be expecting more participants in the next session. And I see there is another question from Sangeetan. When AZ is enabled for a region, the replicas will be spread between different data center in the same region, resulting in higher SLA.
That's right.
That's the question. Okay.
Yeah, that was a confirmation question, but yeah, you're right. So when you implement AZ, then the replicas are configured in such a way that the replicas are not in the same data center, they're distributed, so that even if one data center goes down, you are continued to be served. So yeah, that's a way to provide high SLA. But even if you want higher, then you want to have multiple regions also.
Got it. Okay. Yeah, thanks, Sandeep. Thanks for the insights and answering all the questions. That's all for the session today. I know we have a lot more to cover on Cosmos DB in the coming weeks and months and years. Please share your feedback and don't forget to subscribe the channel. Until we catch you in another session. Bye. Take care.
Thank you, Sajid. Thank you. Bye-bye.
Thanks.